Okay, hello everybody. This video is going to focus on um, angle and segment bisectors and just some of their properties. Now, first let's get a segment in here to bisect, and because we're using Desmos, we're going to have to create a radius, and that radius really can be anything overall. I'm just going to name it here so we have our radius. Now, there is one catch for the bisector, and that is our radius needs to be at least half of this segment's length. So I'm just going to extend it out, lock that back down. So we're going to create a perpendicular bisector. And the way that we do that, if we're using constructions, is to make these two congruent circles, and we see that they overlap, meaning that we can connect a line going right there. And what this has done is has ensured that we have a 90-degree angle here. So we have our perpendicular bisector. Now, here's the big thing about the perpendicular bisector itself. And that's that we can draw segments from anywhere on this bisector to the endpoints. And the thing that's special about this relationship is these two segments have to have the same length. And it doesn't matter where this point is on my perpendicular bisector. If the point is on the perpendicular bisector, then we have this relationship where these two segments are going to be congruent. In fact, this forms an isosceles triangle. That's essentially what we're doing here. So, one of the big theorems that we come across in this unit is this perpendicular bisector theorem. And it says if we have a perpendicular bisector, then any point we put on this line, on the bisector itself, is going to be equidistant from the endpoints of the segment that we're working with. The reverse is true as well. If we have two segments of equal length on a line perpendicular to a segment, then that line has to be the perpendicular bisector. One of the activities that we had at the beginning of the unit was based off of that principle. Now, we also have angle bisectors, and angle bisectors work in a similar way, just a little bit different. So I'm drawing this here. We're going to create an angle bisector doing a construction. And the way that we construct a angle bisector is by making three compass marks with the same radius. The first one centered at the vertex of the angle, and then the other two are going to be at the intersections of that first circle and the other two. Now I'm going to hide those circles just so that we can go ahead and make things look a little bit neater overall. I'm also going to go ahead and hide this radius. Now, this is a bisected angle. The only issue that might occur with this measurement is, given that we are working with a computer, this computer rounds to the nearest whole decimal. This time everything's fine. We can see that it actually is saying that both are 38 degrees, but sometimes it might say one is 38 and one is 37. That's the disadvantage of working in an environment like this. But what we're going to do is we're going to make a point. And we're going to make a couple of perpendicular lines. So both of those perpendicular lines are going to be perpendicular to the side of the angle and going through that point. And I only do this so that we can actually line up two segments so that we can easily see those segments. Then I'm going to go ahead and hide those two lines just to make sure that it's cleaner, so to speak. And we're going to go ahead and verify that these are indeed right angles. Now, here is the neat part. These two segments are going to have the exact same length. And this is always going to be the case. So we could move our angle. We see that we end up with the angle bisector still cutting the angle in half. And those two perpendicular distances remain the same. We can also see that no matter where we are on the angle bisector, those two lengths are the same. This is a result of basically congruent triangles, because if this is an angle bisector, those angles are congruent. This is a right angle, and we have that this segment is always going to be congruent to itself. So basically we have angle, angle, side congruence, giving us two congruent triangles. Now, much like the perpendicular bisector, the angle bisectors have the same type of relationship. And what I mean by that is this. We have if we have an angle bisector, every point on that angle bisector is going to have this relationship with it. If we were to have if we did not know this was an angle bisector, but we knew that this was 3.5 and this was 3.5 and they were both perpendicular, that instantly tells us that this ray bisects the angle, because hypotenuse, leg, congruence of a right triangle. Those are the two big individual theorems from section 5.1 that give us the information that we were originally looking at. Now I'm deleting this stuff again because we're going to put a triangle in here now, and it's just going to be any old triangle. Okay, I'm going to go ahead and clean this up a bit by just hiding the actual interior of our triangle here. So we have a triangle. Now, if we have the perpendicular bisectors of the triangle, which we know go through the midpoints, and they're lines that are perpendicular to the sides, we will see that these intersect each other. Sometimes they intersect each other on the outside of the triangle, sometimes they intersect each other on the inside of the triangle, but they do intersect each other. And that point of intersection is known as the circumcenter. And here's the thing about the circumcenter, which now that I have the circumcenter labeled, we know that it's where these three perpendicular bisectors are intersecting. I am going to hide my perpendicular bisectors just to make the next image a little bit easier. So what this circumcenter is, and you can see it's still attached to the perpendicular bisectors, because as we move around, we end up with the same point here. I'm going to make 3 segments, and those segments are going to go from that point to the vertices of the triangle. So from the circumcenter to the vertices of the triangle. Now these 3 segments all have the same length. And they all have the same length because of the fact that we are dealing with perpendicular bisectors. Remember, any point on a perpendicular bisector is the same distance from the endpoints of the segment itself. So what does this actually do? Well, it acts as the center of a circle that is circumscribed. So that circumcenter is always going to be at the center of the circle. That is acting as our circumscribed, that is circumscribing the triangle. That is where the circle is going through the endpoints of the triangle. But everything is moving around in relationship to how those perpendicular bisectors are meeting. Okay, we have one more thing that we're going to talk about here real quick. I'm going to hide that. And I'm going to go ahead and come in here and make just one more triangle. And again, I'm going to go ahead and hide the interior bit. Now this one, we're going to make 3 angle bisectors. And in order to make an angle bisector here, we are actually going to need a radius. I'm just going to have a very small radius here. And I'm going to go ahead and lock it into place because we really don't need this to shift at all. So there's our radius. Now, angle bisectors we get by doing the same exact compass radius, and we intersect them like this. So I can make the angle bisector for this first vertex here, and that's just going to be that ray. Now, just because this is going to get very crowded. If I don't, I'm going to go ahead and delete that. I'm going to make another compass mark. I'm going to do the same radius that we did on the last one. And we're going to put in our second value here, our second angle bisector, and there we are. Again, I'm going to hide these 3 compass marks, And we're going to do this one more time to get that last side. So compass, radius, and what we should see when we get this one in, and I'm going to move this around a little bit just to make it to where it's going to be easier for us to actually get this value in. We should see that I think I misclicked somewhere. Let's see. I apologize if you hear my cat outside the door. So 1, 2, 3. And that looks to be right. And we get our you can see how it's a little crowded here, but that looks like it went in the right spot. Let's verify. Not quite. So it's not quite in the right spot. Let me try one more time to get this last bit in. So I'm going to extend that out a little bit, and we're going to do the compass one more time. Radius, radius, radius. And this one I think might have lined up properly. What we're looking for is that point of concurrency. Yeah, looks like we have that point of concurrency. But that might be a little off still. The last angle bisector is going to go through there. We know it's going to go through there because that actually acts very much like the perpendicular bisectors. They have a point of concurrency. But what's special about this point of concurrency is it is the center of an inscribed circle. So if we label this, we could label it the incenter. And what that means is if we take the perpendicular distance, this is why this type of stuff can get very busy very quickly. It gives us these 3 lengths. And the thing that's special about those 3 lengths is that they should all be congruent. I'm going to hide some of this stuff just to make those lengths a little bit easier to see. So these 3 lengths, I think one of them is off, but we kind of thought that would be the case when we were having trouble getting that construction to work. They should all be the same value, and we can tell that they're not. I think 2 of them will be. Okay, so 2 of them were, 1 of them wasn't, which means that we had a slight error in our setup, but we could see that we were struggling with getting the construction. In fact, angle bisectors are very difficult to construct overall. But what does this incenter actually do? Well, you can see that it kind of makes this circle here and here. The issue is, since we don't have that third angle bisector, we don't have that situation where everything matches up. Trying to figure out which bisector it is. I think it might have been this angle bisector that we had wrong initially. But let's see if we can't freehand this into place. Yeah, it's rounding at this point to it. But the end center is the value that the three angle bisectors of a triangle intersect. And they allow us to inscribe a circle. So this has been a very long video. I'm going to go ahead and stop it here. But all of these definitions and theorems are found in your textbook in section 5.1 and 5.2. And they have diagrams that are much more nicely written than mine. I hope this helps, and have a wonderful day.